Hi, welcome back. Today's video is on the normal force. Let's get started. Well, the normal force is the force that keeps one object from invading the surface of another object. Call it the normal force. Well, in math, normal means perpendicular. And we always determine the normal force by considering all the forces that have components perpendicular to the surface. Surfaces are really smart. They know exactly how hard they have to push back on an object to keep it from being invaded. Okay, let's see an example. We have here a box sitting on a table, and the box has a mass of 5 kilograms. We want to find out how hard the table has to push on the box to keep it from being invaded, to keep the box from invading the table. Well, first thing that we need to do is draw a free body diagram. I'm going to represent the box by a dot, red dot, and I'm going to draw the forces that I know are acting on the box. The easy one is the force of gravity, or the box's weight. Everything will always have one of those, and they always point straight down towards the center of the earth. Label it m times g, and that's the weight, or the force of gravity. And then the table is pushing up on the box, and we call that force from the surface of the table the normal force. Okay, so there are no forces acting in the x direction. The box is sitting still. Nothing is pulling on it. Nothing is pushing on it. Nothing is pulling on it or pushing on it. There can't be any friction. But that's subject of another video a little bit later on. Well, now it's time to write our equations of motion, our Newton's laws equation of motion. I'm not going to write anything for the x direction because there are no forces acting in the x direction. So let's write our equation of motion for the y direction. Sum of the forces in the y direction are equal to the mass of the box times the acceleration of the box in the y direction, and that's equal to the forces, the sum of the forces. Well, the forces that are acting in the positive y direction, pointing up, normal force, minus the forces that are acting in the down or negative direction. The only force that's acting down is the weight, which is mg. Now, because we have a really smart table here, it knows exactly how hard to push on the box without making the box accelerate. The box is sitting on the table. It has a constant motion of 0. There is no acceleration. So we're going to change the acceleration term to 0 because that's what it equals. That gives us 0 is equal to normal minus mass times the acceleration due to gravity, which tells us that the normal is equal to the mass times the acceleration of gravity, or the weight of the box. So the normal is equal to 5 kilograms times 9.8 meters per second squared, which is equal to 49 newtons. The weight of the box is 49 newtons, mg, and the table has to push up with a force of 49 newtons. Okay, next up is your multiple choice question. Good luck. Welcome back. Now we're going to do something a little bit more complicated. We have our box. It's still sitting on a table, and there's a force pushing on it, pushing down on the box at an angle of 40 degrees. So we're going to start off just like we always do with a free body diagram. Okay, in our free body diagram, red dot for the box, we have the weight, which is mg. We have the normal force, normal. And then there's this 16 Newton force that is pushing down at an angle. So we always put the tails at the dot. And it's 16 newtons. And the angle that it makes with the horizontal is 40 degrees. Okay, now what we need to do is we need to sum our forces acting in the y direction, because that's where the normal lies. So let's start. Sum of the forces acting in the y direction is equal to the mass of the box times the acceleration in the y direction, which is equal to the normal force. Well, next up, we write down the forces that are pointing in the negative direction, the negative y direction, and the first one up is the weight, which is mg, the mass times the acceleration due to gravity. And then the 16 Newton force has a component that is in the y direction. It also has a component that's in the x direction. We're only interested in the component in the y direction, though. And that component in the y direction is opposite of our 40 degrees. And that means that we're going to use the sign. Opposite and sign go together. And this component would be 16 times the sine of 40 degrees. Okay, so that's pointing in the downward direction, so it's minus 16 sine of 40 degrees. The box is not accelerating through the table, so the sum of the forces is equal to 0, which means that 0 is equal to the normal force minus the weight, which is 5 times 9.8, 5 kilograms times 9.8 meters per second squared, minus 16 sine 40 degrees. Rearrange this. Normal is equal to 5 times 9.8 plus, because we're bringing it to the other side of the equal sign, plus 16 sine 40 degrees. Bring out our handy dandy calculator. Calculator says that 5 times 9.8 times 16 sine 40 is equal to 59.28 newtons. Well, let's write that down. So that's 59.28 newtons. 59.28 newtons. And that's what our normal force is. Makes sense. Box weighs 49 newtons. I know that from the last problem that we worked. Plus the part of the 16 Newton pushed down that is in the vertical direction. Total of 59 newtons. Next up, okay, a little bit more challenging problem here. We have a box. Our 5 kilogram box is now on a ramp that's making an angle of 30 degrees with the horizontal. I'm going to start off by making a free body diagram. I know that's really surprising to you by now. I'm going to start off by making a free body diagram. Now, my box, represented by a dot again. The weight is directed straight towards the center of the earth. The normal force is perpendicular to the surface. Normal force. And we can write our equation of motion, Newton's second law equation of motion. But I need to pick a coordinate axis. We could pick the standard xy axis where y is in the vertical plane and x is in the horizontal plane, and we could work with that. Be a little cumbersome. It's easier if we can put the thing that we're looking for, in other words the normal force, on one of the axes so that it only lies in one direction. It doesn't have components in both directions. So I'm going to make my coordinate axis so that the normal lies along the y-axis and the plane, the inclined plane, provides us with our x-axis. Okay, well, what does that do for us? Well, let's write our equation of motion in the y direction. And x. Well, let's see. Sum of the forces in the y direction is equal to the mass of the box times the acceleration in the y direction. And that's equal to the forces acting in the y direction. Well, we have the normal force. The entire normal force is pointing in the y direction. There's no components in the x direction. Minus the components of the forces acting in the negative y direction. Well, we do have the y component of gravity pointing in the y direction, and that would be that component that lies along the y direction. And the angle between gravity and the new y-axis is 30 degrees. It's the same angle as the plane makes with the horizontal. So that's 30 degrees. And our y component of the force of gravity is adjacent to the angle. Adjacent goes along with cosine. So it would be mg, that's the magnitude of our weight, times the cosine of the angle that it makes with the axis, which is 30 degrees. And that's the y component of our force of gravity, or weight. And we'll list it over here in equation of motion, mg cosine 30 degrees. The acceleration in the y direction is 0. Another good reason to put an axis along that direction, rotate our axis so the acceleration is 0 along one of the axes, which means that any acceleration that's happening is along the other axes. Much easier to deal with than having components of acceleration in both directions. That would be 0, which means that our normal is equal to the weight times cosine of 30 degrees. So that would mean that the normal is equal to 5 kilograms times 9.8 meters per second squared times cosine of 30 degrees, which is equal to, let's pull out the handy dandy calculator, and it says 5 times 9.8 times cosine of 30 is equal to 42.44 newtons. 42.44 newtons. And this is less than the weight of the box. Okay, let's see what's next up. Your free response problem. This is challenging. I wish you good luck. Do your best work. We'll see you in class. Bye-bye.